If we take a tuning fork and we place it over top of an open pipe filled with water, what's going to happen is we're going to create what's called a standing wave. A standing wave is basically a wave that is perfectly bouncing off and creating, it basically looks like it's standing. And that standing wave is when you hear that very strong sound. If you actually did this in real life, you wouldn't really hear much until you created that standing wave, and then you would really hear a loud noise. So it's kind of got that resonance, it's got that volume, and that's how you can kind of tell where these things are. But anyway, in order to figure out what the frequency of the tuning fork is just based on the water level, you actually don't need all this information. You can just look at it like this. I drew a wave here, and the most fundamental frequency here would be a quarter of a wavelength. So here's a full wavelength, right? So basically, what has to happen at the water level is what's called a node. There must be a node at the water level because that's where the wave stops. It isn't free to move back and forth. A node is where the wave is fixed. An antinode is the opposite. Where the wave is free to move back and forth at the largest amplitude, I should say. So here's where the nodes would be, and then here's where the antinodes would be. Anyway, the smallest frequent, or the smallest standing wave that we can set up would be just this quarter of a wave here, meaning that would be the fundamental frequency. We could set up more where we have a node here, and then we can go to the next antinode, which would be 3/4 of a wavelength. And that's what this next one is. This one would be 3/4 of a wavelength because it would look like this. So this would be a half and then a quarter. But if we just look at this first one here, we just see it's a quarter. So we know that the distance is equal to a quarter of a wavelength. So the distance is 0.125, and that's equal to a quarter of a wavelength. So we just multiply both sides by 4, and that will give us our wavelength. So let's do that, and we get a wavelength of 0.5 meters. But that's not what the question was asking us. The question was asking, what is the frequency of the tuning fork? And the way that you can solve that is by using the wave speed equation. The speed of a wave is equal to the frequency times the wavelength. And if I'm solving for frequency, I get speed divided by wavelength. Now, the speed of a sound wave in air is 343 meters per second. This is given to you in the book. 343 divided by the wavelength. Put that in the calculator. 343 divided by a half. We're multiplying it by 2, and we get a frequency of 686 hertz.